In the heart of San Francisco stands one of the city's most famous residential skyscrapers. Completed in 2009, Millennium Tower quickly became a symbol of luxury, wealth, and modern urban living. Rising 58 stories above the city, the tower offered spectacular views, premium amenities, and apartments worth millions of dollars. Business executives, technology entrepreneurs, investors, and celebrities were eager to live here. Owning a home in Millennium Tower became a status symbol. The building represented success. It represented prestige. And it represented the booming economy of San Francisco during one of the most important periods in the city's history. From the outside, everything looked perfect. Its elegant glass facade reflected the skyline. Its modern design stood out among surrounding buildings. Residents enjoyed luxury amenities, private services, fitness centers, and breathtaking panoramic views of the Bay Area. Demand for apartments remained strong. Property values continued to rise. Many buyers believed they were investing in one of the safest and most desirable residential towers in America. At the time, few people questioned the building's future. Developers promoted Millennium Tower as a masterpiece of modern engineering and construction. To residents, it seemed like the perfect place to live, the perfect place to invest, and the perfect example of how modern skyscrapers could combine luxury and technology. For years, the tower attracted attention for all the right reasons. But beneath the surface, a hidden problem was already developing. A problem no resident could see. A problem hidden deep below the foundation. And over time, that problem would turn one of America's most prestigious residential towers into one of the most controversial engineering stories in modern history. Because while the city above continued to grow, the tower below was slowly sinking into the ground. The first signs were easy to ignore. A door that no longer closed properly, a window frame that seemed slightly uneven, small cracks appearing in walls and floors. At first, residents assumed these were normal imperfections. After all, many buildings experience minor settlement during their early years. But Millennium Tower was different. The complaints continued to grow. More residents began reporting unusual changes inside their apartments. Engineers were called in to investigate. What they discovered was alarming. The building was sinking, and even more concerning, it was not sinking evenly. The tower was slowly tilting to one side. Engineers knew that movement alone wasn't the biggest concern. The real danger was uncertainty. Nobody could accurately predict how far the tower might sink in the future. Would the movement eventually stop on its own, or would it continue for decades? Residents wanted reassurance, but experts could not provide simple answers. Every new survey seemed to reveal additional settlement, and as public concern increased, so did pressure on developers, engineers, and city officials to explain exactly what had gone wrong. For a structure standing nearly 60 stories tall, even a small amount of movement could become a serious concern. Measurements taken over several years confirmed the problem. The building had already sunk several inches into the ground. At the same time, the tower was leaning farther than engineers had originally expected. The news shocked residents. Many people had invested millions of dollars into their homes. Now they were learning that one of San Francisco's most prestigious residential towers was moving beneath them. As reports became public, media attention exploded. Headlines described a luxury skyscraper that was sinking into the ground. Questions quickly followed. How could such an expensive and modern building experience a problem like this? Was it a construction mistake? A design failure? Or something hidden deep beneath the surface? Engineers continued their inspections. Survey teams monitored the building's movement. Experts analyzed structural data and foundation records. Each new report raised additional concerns. The tower was still moving, and nobody could guarantee when the movement would stop. What began as a few small cracks had become a citywide engineering controversy. Residents demanded answers. Property values became uncertain. Lawyers became involved. And attention turned toward the one part of the building nobody could see, its foundation. Because the real problem wasn't happening above the ground, it was happening far below it. The answer to the Millennium Tower mystery lies beneath the surface. To understand why the building is sinking, we need to examine the ground it was built on. Unlike many skyscrapers around the world, Millennium Tower was not anchored directly into bedrock. Instead, its foundation relied on a system of piles driven into dense layers of soil beneath the city. At the time, engineers believed this approach would provide enough support for the massive structure above. But San Francisco presents unique geological challenges. Large sections of the city were created through decades of land reclamation. Over the years, layers of fill material, sand, clay, and soft sediments were placed over the natural ground. These conditions can be difficult for engineers because soil behaves very differently from solid rock. When enormous weight is applied, soil can compress, and compression means settlement. The Millennium Tower weighs hundreds of thousands of tons. Every day, that weight pushes downward on the ground below. Over time, the soil beneath the foundation slowly compacted. As the soil compressed, the building gradually sank. But sinking alone wasn't the biggest problem. The greater concern was that the tower wasn't sinking evenly. Some portions of the foundation moved more than others. This created differential settlement. In simple terms, one side of the building was moving differently from the other. When that happens, a structure can begin to lean. And that is exactly what engineers observed. Year after year, measurements showed that the tower was both sinking and tilting. Experts began investigating every possible cause. Some pointed to the original foundation design. Others questioned whether nearby construction projects had influenced the ground conditions around the tower. One project received particular attention. The construction of the nearby Transbay Transit Center involved extensive excavation work close to Millennium Tower. Some engineers argued that changes in groundwater conditions may have contributed to additional settlement. Others disagreed. The debate continued for years. Lawsuits followed. Technical reports were published. Independent experts reviewed the evidence. But despite disagreements over the exact cause, everyone agreed on one fact. The building was moving, and it wasn't going to stop on its own. A skyscraper is only as strong as the ground beneath it. No matter how advanced the architecture may be, every structure ultimately depends on its foundation. When engineers design tall buildings, they must calculate not only the weight of the structure itself, but also how the soil below will behave over time. A small amount of settlement is normal. In fact, most large buildings experience some movement after construction. The problem occurs when that movement becomes uneven. Even a difference of a few inches can create significant stresses throughout a structure that rises hundreds of feet into the air. That's why foundation design is often one of the most critical stages of any construction project. Engineers spend months studying soil conditions before construction even begins. They drill test holes, collect samples, analyze groundwater conditions, and build computer models to predict how the ground will respond for decades into the future. In the case of Millennium Tower, the challenge was especially difficult because of San Francisco's complex geology. The city sits on a mixture of natural soil, reclaimed land, and varying underground conditions. Designing foundations in such an environment requires careful planning and long-term forecasting. Unfortunately, even the best engineering decisions can sometimes produce unexpected results years later. And that is exactly what happened here. The consequences would eventually cost hundreds of millions of dollars and become one of the most closely watched engineering stories in the United States. The challenge facing engineers was enormous. How do you repair the foundation of a skyscraper that is already occupied by hundreds of residents? You can't simply lift the building and start over. Any solution would need to be designed, tested, and executed while the tower remains standing. The next phase of the story would become one of the most ambitious foundation repair projects ever attempted on an occupied residential skyscraper, because engineers were about to launch a repair effort costing more than $100 million. As the tower continued to sink and lean, attention quickly shifted from engineering to accountability. Residents wanted answers. Many had spent millions of dollars purchasing homes inside Millennium Tower. Now they faced uncertainty about the future of their investments. Property values became a growing concern. Questions spread throughout the city. Who was responsible for the problem? Was it the developer, the engineers, the contractors? Or was the issue caused by factors no one could have predicted? As concerns grew, lawsuits began to appear. Residents filed claims seeking compensation for financial losses and property damage. Developers, engineers, contractors, and government agencies found themselves drawn into a complex legal battle. Each side presented different explanations for the tower's movement. Some argued that the original foundation design was inadequate. Others pointed to nearby construction activities. particularly excavation work associated with the Transbay Transit Center. Experts were hired, reports were written, technical evidence was reviewed, and for years, the debate continued. The legal disputes became nearly as famous as the engineering problem itself. What began as a luxury residential tower had evolved into one of the most closely watched construction controversies in the United States. While lawyers argued over responsibility, engineers focused on a more urgent question. How could the movement be stopped before the problem became even worse? By this point, engineers knew they could no longer simply monitor the problem. Action was required. The tower continued to sink. It continued to lean, and residents, the challenge was extraordinary. Repairing the foundation of a skyscraper is difficult under any circumstances. Repairing the foundation of a skyscraper that remains occupied by hundreds of residents is even more complicated. Engineers developed an ambitious stabilization plan. The goal was to transfer part of the building's weight away from the existing foundation and onto stronger layers deep below the ground. To accomplish this, crews began installing new piles extending far deeper than the original foundation system. Heavy drilling equipment was brought to the site. Construction teams worked in extremely confined conditions around the base of the tower. Every stage of the project required careful planning. Engineers had to ensure that the repair process itself would not create additional movement. The project quickly became one of the most expensive foundation repair efforts ever attempted on a residential skyscraper. Costs eventually exceeded $100 million. Even then, success was not guaranteed. Some experts remained concerned about long-term performance. Others believed the stabilization system would significantly reduce future settlement. The work continued for years as engineers monitored the tower's behavior and collected new data. Today, Millennium Tower remains standing. The repair project has helped slow the movement, but the building continues to be closely watched by engineers, residents, and city officials. The story of Millennium Tower is no longer just about a sinking skyscraper. It is also about one of the most ambitious engineering repair projects ever undertaken. A project designed to save a building that was never supposed to move in the first place. The story of Millennium Tower is about far more than a sinking skyscraper. It is a reminder that even the most impressive buildings in the world depend on something far less visible, their foundations. From the outside, Millennium Tower appeared to be a symbol of success. Luxury apartments, modern architecture, a prime location in one of America's most important cities. But beneath the surface, a hidden problem was slowly developing. A problem that would eventually cost hundreds of millions of dollars to address. The tower demonstrated an important lesson for engineers. No matter how advanced a building may be, understanding the ground beneath it is just as important as designing the structure above it. A small miscalculation at the foundation level can create consequences that last for decades. The Millennium Tower case is now studied by engineers, architects, and construction professionals around the world. Not because the building collapsed, but because it revealed how complex foundation design can be in modern cities. It showed that even highly experienced teams can face unexpected challenges when dealing with difficult soil conditions and massive structural loads. Today, Millennium Tower continues to stand over the San Francisco skyline. Residents still live inside. Engineers continue to monitor its performance, and the repair efforts remain one of the most closely watched structural projects in the United States. For future engineers, the tower has become a valuable case study. For residents, it became an expensive lesson. And for the construction industry, it serves as a powerful reminder that every great building begins with the ground beneath it. Because no matter how tall a skyscraper rises, its success will always depend on the strength of the foundation below. Thank you for watching. If you enjoyed this video, be sure to subscribe for more engineering stories, construction failures, mega projects, and fascinating lessons from the world of civil engineering. Because sometimes the most important part of a building is the part nobody ever sees.